So guys, here today we will discuss about the Diophantine equation. So first we have to know that what is Diophantine equation. Diophantine equation is of the form ax plus by is equal to c, where a, b all are integers and also these contain the solution in integer form. That equation is called the Diophantine equation. And the Diophantine equation may contain more than one solution also it may contain no solution. So here now today we will discuss about that how can we solve a Diophantine equation. So suppose here we consider the equation ax plus by is equal to c whenever that here if we find the GCD of AB, which is defined by D, and if D is the divisor of A, D is divisor of A, then we can solve it. And next we have to find the condition that what is the procedure that or how to solve the Diophantine equation. So here let us consider one equation, that is 7x plus 11y is equal to 1. So this is a Diophantine equation. So now see here that this one is equation which contains more than one variable. So now we have to check that this equation is contain any solution or not. So how can we solve it? That first we have to find the GCD, that if we GCD of 7 and 11. See here that if we consider it with ax plus by is equal to c, here a is equal to 7 and b is equal to 11. So here we can say that GCD of 7 and 11 is 1, as 7 and 11 are prime to each other. So now here that if we say that, and also we know that if two numbers a and b are prime to each other, then there exist two integers u and v such that au plus bv is equal to 1. So from here we can say that 7u plus 11v is equal to 1. So now here now we have to find the value of u and v. And now we are going to find u and v by using the Euclidean algorithm. So when the Euclidean algorithm, we know that by the Euclidean algorithm that 11 is equal to, we can write 7 into 1 plus 4. Okay. So now here that here if we follow again, that is, if we find the GCD of 7 and 11 by using the division method as we learn it into the very primary level, that is 7 into 1, 7, then 4, 7, 4 ones are 4, 3, 4, 3 ones are 3, 1, 3, 1 is a 3. So we can say that 1 is the GCD. So you see that 11 is equal to 7 into 1 plus 4. So here now we can say that 7 is equal to also 4 into 1 plus 3. And here now that 4 is equal to, now we can write 3 into 1 plus 1. So now we have to find the value of u and v by using this one. So here now we can say that 1 is equal to 4 minus 3 from the last. And now see here that from the second one, the 3 is equal to, we can write 4 minus 7 minus 4. So here what we write, that 8 minus 7. 8 means we can write that 4 into 2 minus 7. And also now from here that 4 is equal to, now can we write 11 minus 7? That is, now we can write 11 minus 7 into 2 minus 7. So here what we get? Here we will get that 11 into 2 minus 7 into 2 minus 7. That is 11 into 2 minus 7 into 3. So we write that 1 is equal to 11 into 2 minus 7 into 3. So if this one, so now that is if we consider it with 7u plus 11v is equal to 1. So now from here we can easily write that the value of u is minus 3 and 11 and the value of v is equal to 2. So now we can also write, now if we want to solve this one, that is the 7x plus 11y is equal to 1. 7x plus 11y is equal to 1. So now we can easily write that 7x plus 11y is equal to 11 into 2 minus 7 into 3. So now and see here that now from here can we write 7 into x plus 3 is equal to minus of 11 into y minus 2. Okay, and so now see here that 7 and 11 are prime to each other, then we can solve it by like this. That is, we can write that x plus 3 divided by minus 11 is equal to y minus 2 by 7. So now we have to find the solution. Is that now we have to take, or now we have to check that how to find the solution. So from here, can we take that x plus 3 by 11 minus 11 is equal to y minus 2 by 7 is equal to t. So now from here we can write that x plus 3 is equal to minus 11t, or x is equal to minus 11t minus 3, and y minus 2 is equal to 7t, or y is equal to 2 plus 7t. And now if we want to find where, and here what is the t, that is t is equal to 0 plus minus 1 plus minus 2 and so on. And now the condition is that to find the integral solution, that is both the value, the minus 11t minus 3, both are greater than 0. And now we have to find the value, the suitable t for which we can find the any integral solution. So let's say that minus 11t minus 3 greater than 0, that means we can write the minus 11t greater than 3, or it is now from here that 11t less than minus 3, or t less than minus 3 by 11, and 2 plus 70 it is greater than 0, so 70 greater than minus 2, or t greater than minus 2 by 7. So now from here we can say that t is lying between minus 2 by 7 less than t less than minus 3 by 11. So now see that, that here between this region there is no integer value, no integer value of t exists, so we can say that this equation has no particular integral solution, but this one, that is x is equal to minus 11t minus 3 and y is equal to 2 plus 7t, this is the general solution of the Diophantine equation, but it doesn't contain no integer solution. So here now we want to take here one example which contains solution, and the equation here we consider, that is 5x plus 12y is equal to 80. 5x plus 12y is equal to 80. So now the question is that how can we find the solution, that is 5x plus 12y is equal to 11. 12y is equal to 80. So now let us discuss. That is here also if we consider with the equation, that is ax plus by is equal to, say here a is equal to 5 and b is equal to 12. So here the GCD of AB 1, or GCD of 5 comma 12 is equal to 1. So we can also say that there exists two integers u and v, that is 5u plus 12v is equal to 1. And here also we consider, the Euclidean algorithm, that is 12 is equal to, now we can write 5 into 2 plus 2, and then 5 is equal to 2 into 2 plus 1, and then 1 is equal to So now from here, now we can write 1 is equal to 5 minus 2 into 2. And also now, here from here we can write that 2 is equal to 12 minus 5 by 2. So that is 5 minus 2 into 12 minus 5 into 2. And see here that from here we can write that this is 5 minus 2 into 12 plus 4 into 5. And this is 4 into 5 means 20 plus 5, 25 minus 2 into 12. So here we can write this is 5 into 5 minus 2 into 12. So here if we consider with u and v, we can say that u is equal to 5 and v is equal to minus 2. And see here, this is the question that is given that 5x plus 12y is equal to 80. So here we can write that 5x plus 12y is equal to 80. That means 80 into 1. So here we can write that 80 is into, we can write 5 into 5 minus 12 into 2. So now here we can say that it is, we can write 400 into 5 minus 160 into 12. You can see here. And now see that both the equation is of the form that is 5x plus 12y is equal to 400 into 5 minus 160 into 12. So now from here we can write that 5 into x minus 400 is equal to minus 12 into y, or we can say that this one is 12 minus, oh sorry, this is minus 12 into y plus 160. So now from here we can say that x minus 400 by minus 12 is equal to y plus 160 by 5. See here that 5 and 12 are prime to each other. So now here we can write here t. So now see that from here we can write that x minus 400 is to minus 12t, or x is equal to minus 400 plus 12t, and y is equal to 5t minus 160. And now if we want to find the solution, then these both are greater than 0. So 5t minus 160 greater than 0 means t greater than 32, and minus 400 plus 12t greater than 0 means we can write also that 12t, sorry, this one is minus 12t, minus 12t plus 14. There is a calculation mistake. That is x minus 400 is equal to minus 12t, and x is equal to minus 12t plus 400. This is greater than 0. So from here also we can write that is minus 12t greater than minus 400, or t less than 400 by 12, that is less than 100 by 3. That is, we get that t is less than 33.1 by 3. So now see here, the t is lying between 32 less than t less than 33 of 1 by 3. And if we now point out the line, this is the point 32, this is 33 of 1 by 3, and in between there exists one integer is 33. So now we can say that for t is equal to 33, we can get the one integral solution. And the solution is of the form that x is equal to minus 12 into 33 plus 400, and y is equal to 5 into 33 minus 160. And if we solve it, we will get the value of x is 4 and y is 5. So the solution of the Diophantine equation 5x plus 12y is equal to 80 is x is equal to 4 and y is equal to 5. So now I hope you understand that how to solve the Diophantine equation. So thank you for watching the video.